All right, for ionic bonding, what happens with the electrons? Are they shared or are they transferred?
Transferred.
They are transferred. Oops. You guys can see my screen, right? Are you guys on my screen with the periodic table? Okay. All right, good. So yes, they are transferred. There we go. Transferred. Okay. That's what happens with electrons. So as a reminder, okay, if you're looking at, if I just give you a formula, okay, like if I say LiCl, okay, remember we haven't learned covalent yet, but we will, okay, so you have to be able to look at this formula and tell me whether it's ionic or covalent. Now we haven't learned covalent yet, but we will after break. And so you need to know how to be able to distinguish between ionic and covalent, okay? Ionic is between two types of elements. Anybody remember where they are? So like this element is different from this element, how?
Metal and non-metal.
Excellent, yes. Metal and a non-metal, okay? And it's always in that order. It is always in that order. You always list the metal first, okay? And then it's always followed by the non-metal, okay? Can somebody tell me anything they know about metals in terms of electrons or charges? Like, for instance, can you tell me what charge a metal always forms? Positive or negative? It always forms a positive charge. Great. All right. And what do you call positive ions? Your options are anion or cation.
Cation.
Cation. Very nice. Cation. And we know that it's a positive one because the T looks like a positive. All right. And so then if it's getting a positive charge, is it gaining or losing electrons for it to end up with a positive charge?
Losing.
It is losing electrons, okay? If you lose electrons, that means now you have more protons than electrons, you have a positive charge. Now, on the other side, everything's gonna be the exact opposite. So instead of plus, we're gonna have what for non-metal?
Minus.
Minus. All right, instead of cation, it's going to be an
anion.
Anion. Excellent. Somebody knows what they're doing. And then over here, we're also going to have gaining electrons. Okay. So that is how we can tell the difference between, because when we get to covalent, for example, covalent is going to be made with two non-metals. It's going to be made with two non-metals. Okay. All right. So that is a metal and a non-metal. That's how you know it's ionic. All right. So now let's just kind of refresh ourselves on how to name an ionic bond. Okay. So well, let's go back to the one we just had. You had LiCl. Li, what's Li?
Lithium.
Paul, thank you. Excellent. Oops. You do need your periodic table if you do not have it. All right. And then Cl is what element, but we're going to change the ending. You can tell me either the element or you can tell me what it is with the ending change.
Chloride.
Chloride.
Excellent. Chloride. All right. So remember, when we're naming ionics, we name the first element, which is the metal. We name the metal. All right. And then the second one, instead of saying chlorine, we say chloride. Chloride. Okay. Chloride. All right. That's lithium chloride. All right. I'm coming to you, Brooklyn and Chloe. Coming to you too. All right. Here's another one for you guys. You guys can do this one together. How about let's space. We don't need this just yet, so I'm gonna make space. All right. How about this? K2. All right, Chloe, Brooklyn. Brooklyn, how about K? Can you tell me what K is? And then Chloe, you can tell me what O is. Okay, good, Chloe, but see if you can change the ending for me. Brooklyn, are you there? Okay, Brooklyn said K is potassium. She's right. And then Chloe originally said that O is oxygen. And she's right, but we need to change the ending. So let's see if she changed it correctly. Can somebody, yes, excellent. Chloe said oxide. Very nice. All right, so this is potassium oxide. Notice on this one I had numbers, it didn't matter, okay? Name the first element, second one, the non-metal, you just change the ending to I. Let's do another one. All right, this one's going to be for Luis and Cade, okay? Ready, Luis? All right, great. All right, Luis, you just tell me what MG is. Yes. And then Kate, you're telling me CL, what the ending is. Actually, Kate, let's make that a Kate, I'm changing yours. It's going to be this. All right, you find this? It's on the left side. Because there's some metal. MG, yes. All right, okay, Luis said magnesium for MG, he's correct. And then Cade for BR.
I know it's bromine, but is it going to be a different ending because where it is on the table?
It is going to be a different ending, yes. So magnesium what?
I'm going to guess bromide, but I don't think that's right.
Bromide is correct.
Oh, it is? Okay.
Yep, we're just changing the ending to IDE, that's it. All right, so it doesn't matter, listen, all these, it's just the first element, name the first element, second element, name it, but then change the ending to IDE. It's that simple, okay?
So the ending doesn't change depending on what part of the table it's on. It just changes to I.
Say that one more time.
So it doesn't matter where the element is on the table, then it just changes to I regardless.
It's always going to be to the right of the staircase because it's always a metal then a non-metal. So if you notice CL, O, BR, they're all over here. Because when we write it, it's always a metal followed by a non-metal. So the non-metal always gets the IDE ending. Does that make sense?
Yes, thank you.
So your metals are all over here. Anything over here, you just name it as is. That's your metal. All right. And then anything over here to the right of the staircase, you just change the ending to IDE. So for example, let's just kind of quickly go through what some of these would be. All right. How about, all right, Kay said this was bromide. We did chloride already. We also did oxide. Somebody give me what F would be. It's fluorine, so now it would be what? What is it?
Fluoride.
Fluoride, excellent. All right, how about I? Anybody for I? It's iodine. Now it's gonna be iodide. We talked about S yesterday, or the other day. That one's kind of tricky. It's sulfur. Elizabeth, what do you think this one's going to be? Sulfur. Change your ending. Elizabeth, sulfur, please. Not there. Ariane, sulfur, please. I want to change the ending. What do you think it should be?
Sulfide.
Sulfide. Excellent. Thank you. Sulfide. Sulfide. All right, one more or two more. N. And Angel, you can give me N. You there, Angel?
Yeah, I'm here.
Okay. Can you tell me what element it is?
Nitrogen?
It is nitrogen. So this one's kind of weird. So it's nitrogen. We're gonna drop all of this. So now what do you got?
I don't really know how to say it. I think it's like, does it end with IDE?
Yes, they all end in IDE. So what you got?
Nitride?
Nitride, thank you, nitride. All right, and then the other one is phosphide. The P below that is phosphide. All right, so now let's talk about how to write formulas and then we'll do some practice. All right, so now if we're writing a formula, right, if we're writing a formula for something, so for instance, if I gave you, let's figure out why I wrote LiCl for lithium chloride. All right, here's lithium chloride. All right, lithium chloride. I give you the name. The first thing you got to do is write the symbol. Somebody give me the symbol for lithium.
Li.
Li is the symbol for lithium, all right? And if you already found Li, you should also be able to tell me the charge. Hopefully you wrote down your charges the other day. You might know the charge for lithium. We'll come back to it. How about chloride? What symbol is that? Cl, thank you. All right, let's talk about charges really quickly one more time. All right, charges come from when those atoms gain or lose electrons, from when they gain or lose electrons, all right? If we're talking about the fact that, for instance, group one all have one valence electron. Who does everybody want to look like? What family? What is it?
Noble gases.
Everybody wants to look like noble gases. So for instance, sodium with his one valence electron can add 1, 2, 3, 4, 5, 6, 7 valence electrons and look like argon, or he can lose his one and go backwards and look like neon. What do you think is easier, to gain 7 more things or just to lose one? Lose one thing, all right? If he loses his one valence electron, okay, now instead of having 11 protons and 11 electrons, you say he just lost an electron, so now he has 10 electrons. So now he has one more positive thing, which gives him a +1 charge, okay? If you can remember that this is your halfway point, ±4, okay? There's a trend, +1, +2, +3, go backwards. This is ±4, -3, -2, -1. Those are your charges. You do need to know those. So again, I'll ask you, what is the charge for lithium?
+1.
And the charge for chlorine?
-1.
-1. At least I know James and Paul know this one. Excellent. All right, +1, -1. We have to get our charges to be equal to 0. When I add these up, do they equal 0? +1 and -1 equals 0. Great. So that is the formula, LiCl. I don't have to do anything to it. So let's do one where we do have to do something to it. All right. So that was lithium chloride. How about no, let's do calcium iodide. Ariane, I need the symbol in charge for calcium. And Gibson, I need the symbol in charge for iodide. Ariane's giving me the symbol in charge for calcium. Gibson's giving me the symbol in charge for iodide.
Is calcium Ca?
Yes, and do you know the charge?
Negative.
I need a number. We just wrote them across the top.
Oh,
Gibson, are you there?
Yes, ma'am.
All right, do you have yours?
Is it I and 7?
No, charges can only go up to ±4. We just wrote our charges across the top of the table. Everyone should write down their charges across the top of their table.
Oh, it's -1.
-1, thank you. Ariane, did you find your charge for calcium?
no.
Somebody tell me the charge for calcium, please. Tell Ariane. +2, thank you. Everybody right now, if you have a periodic table or if you don't, you are going to stop right now and everybody's going to write their charges. Let's do this one more time. The charges are right here across the top. You're halfway through. Noble gases don't have a charge. Why? Because they don't want to gain or lose anything. So they are 0. You don't even have to write it, but these are 0. Let me write this sticker. +1, +2, +3, plus or -4, -3, -2, -1, 0. Please write down your charge. Give you 30 seconds. All right. Hopefully you got those down. The middle one is plus or minus 4. Right here is plus or minus 4. You got that, you should be able to see the trend. Plus or minus 4 is right here. All right. So here we were back to our question. We had Ca with a +2 charge and I with a -1 charge, calcium and iodide. When I add those up, do they equal 0? Is a +2 and a -1 added together?
No.
Right, it's a +1. So what we have to do is either add some more calcium, so I could add another calcium that has a +2 charge, or I can add an iodine that has a -1 charge. Which one's going to help me get closer to 0? Add another iodine. So if I add another iodine right here, which also has a -1 charge, are these equal to 0 now? Yes. Okay. So now here, those are just charges. Okay. Subscripts are little numbers that tell us how many of each we need. Okay. So when I write the formula, we use subscripts. So if I look at this, okay, it's a calcium iodide. How many calciums do you see? We only have 1. Okay. You can write the 1, but we really don't have to because we already wrote calcium. So we know we have at least 1 of those. Okay. Then we had an iodine. How many iodines did we have? We had 2. So that's why it gets a little 2 down here to say that you had 2 of those iodines. Okay. That's what that means. So the formula for calcium iodide is CaI2. CaI2. All right. We're going to do one more because we already did this the other day. Okay. All right. All right, let's do all right, here we go. Magnesium. No, let's not do magnesium. We've done magnesium a lot. Beryllium. Phosphide. Beryllium phosphide. All right, here are your steps. First thing is write your symbols. Find Be, find beryllium, find phosphide, write your symbols. Your next step is to write your charges over your symbols. That's the first thing I want you to do. Write your symbols and their charges. Symbols and their charges. All right. Anybody got this symbol and charge for beryllium? Be and a +2 is what I heard in here. That is correct. Be and a +2. Phosphide. Phosphide. You might got that one.
It's just P, right?
It is just P, correct. And what's the charge for P?
-1.
Cool, not quite. So remember,
-2.
2.
nope, not 2 either. So here we go. Remember, this is ±4. This was +3, -3 right here. -3, -2, -1. Everybody with me there? Okay. Don't look at this. If you're looking at this, don't look at this yet. I haven't taught that, but I'm about to. All right. So everybody understand why this is -3, yes? All right. All right, here we go. So -3. So some of you guys, I think now you had given me an answer. Now try to make adjustments. Okay. So now we have our symbols and their charges. Symbols and their charges. Figure out how many you need. You may need to add some to both of them. Okay. But remember, the whole point is we need to get the charges to be equal to 0. Okay. So take a second. Try to get your charges to be equal to 0 by adding more BEs or PEs or both. Take a second, see if you can figure that out. All right. You guys in here got it. I know James got it. Anybody want to give it a go? Kate, what'd you get? Let me know what you got, Kate. Kate, are you there?
I'm here. Sorry, I just haven't gotten it yet.
Okay. Gibson, you want to give it a go?
I haven't gotten it yet.
Okay. Anthony?
Yeah.
You want to give it a go? Do these, if I add these up, do they equal 0?
Mm,
If I add these two together, do they equal 0?
No, they don't.
no.
No.
No, they don't.
All right, so I need to get these to be equal to 0. So maybe I need to add another P, or maybe I need to add a BE. I can add either or neither of these. What do you guys want to do?
You need a BE, so it's going to be BE with a foot of 2 and then P.
Okay, so you're saying I need another BE, so that's another +2. That gets me to 4. What's the least common multiple between 3 and 2? What can I multiply those numbers by and they equal the same number? Least common multiple between 3 and 2. Any guesses?
6.
6. Excellent. So what do I need? How many of these do I need to get this to 6? This is a +2. So how many do I need of these altogether?
3 times.
3.
3 of them. So here's another BE. Here's another +2. So now these 3 together equal +6. All right. Now over here, this 3, if I add another one, what's that equal to? If I add these together? -6. Very nice. If I add these up, do those equal 0?
Yes, sir.
Yes, they do. All right, fantastic. So now we've got them to cancel out. Let's write what our formula is. We know we had a BE and we had a P, but we've realized we needed 1, 2, 3 BEs. So that's BE 3. And we needed 1, 2 P's. So that's P2. So your formula is BE3 P2. BE3 P2. This little number down here is called a subscript. This little number is called a subscript. Okay, it tells me how many atoms of that element I need. For example, if you see H2O, that means I have 2 H's and I have 1 O. Okay, if you see C2H3O2, that means I have 2 carbons, 3 hydrogens, and 2 oxygens, all connected. That's what that means, okay? All right, let me teach you one more thing, and then you guys are on your own, okay? All right, here we go. Any questions on that before I erase it? Okay. All right, so we talked about an ionic bond. Teach you one new thing, okay? We talked about an ionic bond being between a metal and a non-metal, okay? There's another thing, okay, and I'm sorry, this is the wrong symbol. There's another thing it can be between. It can be also be between a metal and a polyatomic. A metal and a polyatomic, all right? Somebody tell me what does poly mean? Multiple or many, right? Multiple or many, poly, all right? So these are polyatomic ions. They are on the back of your Chem Cruncher, which you should have, which you need, okay? So poly means, this poly means many or multiple. Many or multiple. Atomic sounds like what word? Atom. So many atoms. And then an ion is just the ones with a charge. Remember, ion just means you have a positive or negative charge. So this is a list of polyatomic ions. Now, when I was in school, I just had to know these, but I'm really nice and I just gave them to you, okay? So they're on the back of your Chem Cruncher. Remember, your Chem Cruncher is in Schoology, as well as on OneNote, okay? So give me 1 second. Oops. All right, so we talked about a metal being ionic being a metal and a non-metal. The other thing you can have is a metal and a polyatomic. Okay, polyatomic. So this is your table of polyatomics. It is literally the same thing, and actually it's even easier to name it, okay? It's even easier because you don't have to change the name of the polyatomic at all. You name the metal, you name the polyatomic, okay? So I'm gonna give you one, and I want you to just try to guess. Remember the numbers don't matter, okay? Now let me just talk about the polyatomic table for a second. For example, chromate, right here. Chromate is CrO4, and then it has, I told you the charge is -2. So the -2 is not necessarily part of the formula. It's just telling you that's the charge, okay? It's like me saying Li plus 1, okay? So chromate is just CrO4. It's just saying that the charge is -2. That's what that means, okay? All right, so with that being said, okay, the charges are the same except for I just gave you the charge on these. All right, let me give you an example. All right. All right, you're gonna have to look at your periodic table and your polyatomic chart. Okay. Name the first element, name the polyatomic. Name the first element, name the polyatomic. Remember, if you see more than 3 elements, okay, if you see more than 3 elements, you have a polyatomic. So earlier we were doing stuff like LiCl or NaBr. That's 2 elements. 1 element, 2. 1, 2. Down here I have 1, 2, 3, 4 elements, because every time you see a capital letter, that's a new element, okay? So anytime you see that, that tells me I must have 1 element, and then I must have a polyatomic attached to it. All right, so, yes. Yours, guys, mine has a chief on it. I couldn't find my updated one. Okay, yours has a big Marietta M on it. Okay, which it should. Mine should have that too. All right, so, Paul, how about K? What element is that?
Potassium.
It is potassium. All right, we've named the K now. That is potassium. Now, you guys look on your table of polyatomics and tell me where you see something that looks like C2H3O2. And tell me what the name of it is. Anybody see it? You're now looking at this table right here. C2H3O2. C2H3O2. Everybody sees it over here? What do you see, Mandy? I don't know. Acetate. Mandy says acetate. She is correct. All right. It is right here. C2H3O2. So this is potassium acetate. It's that easy. That's the name of this. Potassium acetate. Okay, potassium acetate. All right, let's do another one. All right, how about all right, see if you can find that one. Name your first element. The rest of it must be a polyatomic. I put RB2. But remember, your numbers do not matter. Know your name. Yes, RB2. All right, Chloe, give me my first element. Thank you. Chloe says rubidium. And then Teresa, can you find the polyatomic that goes with this? That's left over. You should be looking on this chart and finding something that looks like what's left over. So rubidium was here.
I don't really know.
You just have to find it on the chart. Somebody find it on the chart. Thank you, Mandy. Mandy says it's sulfite. She is correct. Sulfite. SO3. SO3. Sulfite. One more. Actually, we're going to go backwards. Now I'm going to give you the name of it. Let's figure out the symbol for it. I mean, the formula. Okay. All right. All right, just like we did before, find your symbol for barium, find your symbol for hydroxide, put your charges. Okay, find your symbol for barium, find your symbol for hydroxide, that looks like a polyatomic. Put your charges, and then we'll see if we can get them to cancel out. Angel, you can give me the symbol for barium when you get it, and the charge. And then whoever can give me, good job, Brooklyn. Brooklyn said barium is Ba and it has a +2 charge. She is correct. Who found hydroxide? Nobody found hydroxide online. Who found hydroxide? I'll take anybody. Close. All right, Brooklyn said it's OH. So somebody find OH and tell me what the charge is. Charge for hydroxide is a -1. -1. All right, so how many, what do I need more of, baryons or hydroxide?
Hydroxide.
I need another hydroxide, that's another OH, -1. Does that get me charged to 0?
Yes.
right. Watch carefully what I do, okay? So this is Ba, OH, I needed 2 OHs, okay? I needed 2 OHs. Watch very carefully because somebody's gonna miss this. If I just put a 2 here, it looks like I need 1 oxygen and 2 hydrogens, okay? For me to say that I need 2 hydroxides, I have to hug them and keep them together. So I'm gonna put parentheses here, okay? That tells me I need 2 hydroxides. OH2 looks like O and 2 H's. OH in parentheses with a 2 looks like an OH and another OH. Okay? Parentheses are very important when you're doing polyatomic. Okay? All right. So now we're going to get ready to do some practice. I'm going to stop recording.